In this video, a topic of discussion is going to be laws of reflection based on wave theory. That is, using Huygens construction, how are we going to prove the laws of reflection? So we know that the laws of reflection is the angle of incidence, angle of reflection are the same. Similarly, the incident ray, reflected ray and the normal all lie in the same plane, right? So to start with the construction, first what we are supposed to do is we need to take two incident rays which are parallel to each other. Let this be the first ray, let this be the second ray, which are incident on a mirror M1, M2. Okay. So if you observe, these two are inclined and they are hitting the surface in such a way that the first ray is hitting the surface and the second ray is taking some extra time to hit the mirror, right? So by the time the first ray is hitting the surface, let's say it is at instant t is equal to 0. Now the second ray was at point B dash by the time the first ray was at point A, right? So after these incident rays are drawn, what we need to do is, the first thing is we need to draw the incident wavefront. So we know that incident wavefront, that is a wavefront, is perpendicular to the ray. So by taking the perpendicularity, I just drew an incident wavefront. Okay. So with that incident wavefront, we could identify that the second ray was at point B dash by the time the first ray has hit the surface at point A. So in the next t seconds or t time interval, the second ray would have travelled an extra distance of B dash B, which is given by the expression c into t, because we know the distance is equal to speed into time. So the extra distance travelled by B dash B before it hits the surface after time t is going to be c into t. So what we are supposed to do is, we know that by the time the first ray has hit the surface, it would have started generating spherical wavefronts, because the first point says every point on the source behaves like every point on the incident wavefront behaves like a source for the secondary wavefront, right? So by the time it hits, it starts generating a spherical wavefront. So in the extra time t, that is by the time B dash B has travelled a distance ct, the wavefront at point A would also have travelled a distance ct. So for that to happen, what we are supposed to do is take a compass, measure B dash and B. Okay. Once we measure this distance, with A as a center, cut an arc of radius ct. So once you cut the arc of radius ct, from the point B, draw a tangent to the secondary wavelet. So there is a secondary wavelet. To the secondary wavelet, if we draw a tangent, this gives us the reflected wavefront, because we know the tangential surface to the wavelet is going to give us the wavefront. The tangent which is drawn from the second point of incidence to this secondary wavelet, which is generated by the source at point A, will give us the reflected wavefront. So this is the point at which the tangent is considered, right? So this is the point of contact for the reflected wavefront. So from point A, if you join A to the point of contact, that gives us the reflected ray, because it's very simple that we know that wavefront and ray are perpendicular to each other. So when you draw it in such a way, then this reflected ray is there, so that if this is taken as angle of incidence, then this is going to be angle of reflection. In a similar way, what we can do is, to this reflected wavefront, if you draw a perpendicular at this point, so perpendicular to this one, this will give us the reflected ray, because this reflected ray is also perpendicular to this wavefront. Okay. So if you draw a normal here, okay, observe. So if this is I, then this angle will be 90 minus I, right? Since this is the normal to the mirror, if this is 90 minus I, this is going to be I, this angle is I. Similarly, if I take this angle as R, then this angle will be 90 minus R, so The remaining angle here is R. So our work is to prove that angle I is equal to angle R. For that we will take the help of geometry. If you observe, there are two triangles which we can consider. One is triangle A-B and triangle A-B-NB. So if you observe, in this angle A dash is equal to angle B dash is equal to 90 degrees, right? Similarly, A dash is equal to B dash. Both are equal to CT because this is what we have taken as the radius and we have constructed the wavefront. Similarly, if you observe, AB is a common side, right? So since all these conditions are satisfied, we can say that triangle A-B is congruent to triangle A-B. When two triangles are congruent, we know that the angles are going to be the same. So which implies angle B